Moham, are you there? Um, hmm.
If you need us to, we can go to the next group and come back to you.
Oh, okay, I'll do this for him. So our product is to predict breast cancer survival rate. So with the use of data sets from NKI, our team works together on a product that helps estimate the survival rate of a breast cancer patient. This is done with the help of models such as SVM, random forest, and linear regression. In addition, our product also recommends treatment plans based on those predictors. Our mission is to assist breast cancer patients by offering a clear, accessible, and simple to understand website that examine data provided by users to estimate survival rates and display common treatment options. Our product can potentially make it possible for doctors and patients to individually customize screening and preventative programs, decreasing the likelihood of a late diagnosis.
Our data exploration. So here you'll find various visualizations that pertain to our data set. These graphs explore things like the relationship between time recurrence and survival rate, treatment types to survival, and age to treatment, just to name a few. Right here we have some scatter plots. So this first graph explores the relationship between time recurrence and a patient's survival rate. The x-axis is the recurrence and the y-axis is the survival. This graph shows that there's a positive correlation between time recurrence and patient survival rate. Down here we have this graph explores the relationship between survival, time recurrence, and age. With this, it shows that there's a positive correlation between some of those variables. This graph here displays the relationship between age and time recurrence. Those in older age groups were more likely to have a recurrence of breast cancer than those in younger groups. And our last graph displays the relationship between age and survival. People across all age groups had different survival rate. However, the survival rate did seem to increase among older populations. Pass it off to the next person. Or not, I could do this one too. Here's some common treatments. This is a graph showing the relationship between time recurrence and survival while also taking one of the common treatments for breast cancer, chemo, into account. With this, it shows a positive correlation between those variables, which means that chemo can be an effective treatment. This graph shows the relationship between time recurrence and survival while also taking hormonal treatments into account. With this, a positive correlation was shown, meaning the hormonal treatments can also be quite effective. And then you can interact with the graph and move around. Above is a visualization of the relationship between survival, time recurrence, and amputation, which is another common treatment for breast cancer. The positive correlation in this graph indicates that amputation can also be a good treatment. This is a visualization of the relationship between survival, time recurrence, and his type. His type stands for histological type, which is a description of a tumor based on how abnormal the cancer cells and tissue look under a microscope, as well as how quickly the cancer cells are likely to grow and spread. With this, histological type can also be a helpful thing to take into account when deciding what treatment plan would be most effective.
So for our project, since we're trying to predict rates for breast cancer, we used machine learning modules to make predictions using survivability rates, using patient data, and these included linear regression, supported vector machine, and random forest classification. So for linear regression is a system to predict the model and relationship between multiple variables, which in this case is the survival rate and the time reoccurrence, and it makes a prediction with a line. And in our data set, we use linear regression to calculate the MAE, or the mean average value, to find the average value of these data points and analyze the variability. And our MAE was about 8.5559.
So here we have a support vector machine. We have a confusion matrix, which is a type of SVM, right? And for this matrix, the X values were age and time recurrence, and the target variable, which is the variable we were trying to predict, was the survival rate. Overall, this matrix shows that after training the algorithm, it was able to have an accuracy of 80% because out of the 55 values given, it was able to predict 44 correctly.
So we worked on an sklearn breast cancer dataset to build a random forest classification model that classifies breast cancer patients as either low or high survival rate. After performing a simple EDA to determine the most important features in the dataset, analyzing the features and testing different sizes, we obtained a final model with an 88.7% accuracy.
So overall, my team has learned a lot from the past 3 weeks. While working on this project, our group came a long way to assemble this whole stuff, especially considering that the majority of my team had no coding experience previously. So I was just impressed that they can complete this wonderful product in such a short time. So I want to shout out to all of them.
All right, so here's the model. So I'm just going to fill it out with some variables. So the ones and zeros mean whether or not they got the treatment. One being like, yes, they do use this treatment, and 0 being that they have not received that treatment. And so for this one, the predicted survival rate was 4%, which is actually quite low. And also remember, those seeking medical advice should consult with a licensed professional or a healthcare provider. This model is definitely not a substitute for professional medical advice. And here's the team section.